Next question is XYZ Co-Limited is a costless monopoly from suburban Mumbai producing and selling exotic mushrooms. The demand for mushrooms is given by Q is equal to 700 minus 10p, where Q is quantity, P is the price. The question tells us, do you agree XYZ will have maximum possible total revenue of 1500? We have to see whether it has a maximum possible revenue of 1500. First of all, we will solve this very function for price. When solving this for price, so P is equal to this will become 7 minus Q divided by 100. Okay, this is our price function. Now total revenue is simply, now total revenue is equal to price into quantity, price into quantity. This becomes, we multiply this very function with Q, so this will become 7Q minus Q square divided by 100. Okay, now this is our total revenue function. We know that total revenue is maximum. Total revenue is maximum when marginal revenue is equal to 0. So we'll differentiate this function with respect to quantity. So this is our total revenue function. Then our marginal revenue function is the derivative of total revenue function with respect to quantity. So this becomes 7 minus this 2 becomes coefficient. So 2 divided by 100 is 1 divided by 50. So we get Q divided by 50 and set it equal to 0. As I have told you, total revenue is maximum possible only when marginal revenue is equal to 0. When setting it equal to 0, we will get Q divided by 50 is equal to 7, or Q is equal to 350. So our quantity is Q is equal to 350. Now putting this Q is equal to 350 into total revenue function, our total revenue function is this very function. So our total revenue would be equal to 7 into 350 minus 350 square is equal to 350 into 350 divided by 100. I will write here divided by 100. When solving this will come out to be 1225. Okay, so maximum total revenue possible is 1225. So we can say that the maximum possible total revenue is less than 1500. So option I will write here. So no maximum possible revenue is less than 1500. So we got the maximum possible revenue is 1225. We can say maximum possible revenue is only 1225. So the condition is same. Marginal revenue is equal to 0 will give us the total revenue as maximum, or our total revenue is maximum possible only when our marginal revenue is equal to 0. Another question that was asked in the GATE economics paper of 2021 is, a firm finds that for the product it produces, its own price elasticity of demand is 4. Currently the firm is selling 2000 units per month at ₹5 per unit. If it wishes to increase its sales by 10%, it must, the options are, lower its price by 4%, increase its price by 2%, lower its price by 2.5%, and last option is lower its price by 2%. So this is a question. This is a tricky question, I guess. First we will see what is given. We are given price elasticity of demand is given as 4. Now what does this tell us? This 4 is the price elasticity of demand. It simply says as 1% decrease in price will lead to 4% increase in total revenue. Here it is sales. Sales or total revenue is same here. Similarly, if there is 1% increase in price will lead to 4% decrease in total revenue. So here we are given the sales. Now we have to do nothing with this 2000 or 5. What is given the number of units it produces, or what is the price? The question tells us if it wishes to increase its sales by 10%. So let us say we have this relationship of 1% decrease in price leads to 4% increase in total revenue. Okay, so we will see here 1% increase in total revenue will lead what percent decrease in price. So we can write it here. So we will use the unitary method. Therefore 1% increase in total revenue will lead to this 4 will become this will become 1 by 4% decrease in price. Okay, now we have solved this for unitary method. For 1% decrease in price gives us 4% increase in total revenue. Then 1% increase in total revenue will give us 1/4 1 by 4% decrease in price. Okay, now 10% increase in total revenue or total sales will simply lead to 10 into 1 by 4% decrease in price. That means 10 by 4 is 2.4% decrease in price will lead 10% increase in sales. So I repeat here, since the relationship is given as 1% decrease in price leads to 4% increase in total revenue, then 1% increase in total revenue will give us 1 by 4% decrease in price. Now we are told what will happen if it wishes to increase its sales by 10%. That means 10% increase in total revenue will lead to 10 into 1 by 4% decrease in price. That is 2.4% decrease in price. Okay, I hope I make myself clear. So I guess the right option to this question is this. Sorry, it is here 2.5. I have miscalculated this, so this is 2.5. So the correct option is C option, that is lower its price by 2.5. So this was a tricky question. Next question is, as economic development proceeds, income inequality tends to follow dash dash curve. The options are inverted U-shaped, V-shaped, asymptotically convex, or S-shaped. So the correct option to this question is this option, that is inverted U-shaped, because this is the Kuznets U curve, inverted U curve, that is looks like this. We have the development on this axis and inequality on vertical axis. The Kuznets inverted U hypothesis tells us as development increases, inequality initially increases, but with the passage of time the inequality tends to decline. So the correct option would be inverted U-shaped. Next question is, a government security is a tradable instrument issued by the central government. B option is cannot be considered as gilt-edged instrument. C option is can have maturity of only more than 1 year. D option is a tradable instrument issued by the state governments. So the government security are of two types. One is that has the maturity period of less than 1 year, and we call them treasury bills or T-bills. And second one is which has the maturity period between 1 year and 40 years, and we call them government bonds. Okay, so there are two types. Also the government securities are used by the central governments and state governments also. So option A and D are correct. C can have maturity of only more than 1 year. No, they can have maturity of less than 1 year also. So I guess this option is not correct. Cannot be considered as gilt-edged instrument. Government securities are considered a gilt-edged instrument as they are risk-free. By gilt-edged means they are risk-free and they are backed by the government. So the correct option to this question is they are tradable instrument issued by central government, is a tradable instrument issued by state government. Second, C option was can have maturity of only more than 1 year. It is not only more than 1 year, it could have less than 1 year maturity period, and in that case we call them the treasury bills. If it has the maturity period between 1 year and 40 years, we call them government bonds. Okay. The first question is the long run cost function of all identical firms in a perfectly competitive industry is given by the function that is cost is 25q minus 3q square plus 1.5q cube. The market demand function is given by that is p is equal to 2500 minus 0.25, where q is the total quantity and p is the price. The number of firms in the industry at equilibrium is, we have to find the number of equilibrium firms. So how we will find that? First of all, we are being told about the long run. Okay, we know that in long run, in long run, price should be equal to marginal cost, which should be equal to average cost. This is the equilibrium condition for any individual firm's output level, optimal output level. So this condition must be held. Okay, so we will find the marginal cost and average cost. Okay, our average cost is simply, so I will write our total cost function is given as 25q minus 3q square plus 1.5q cube. Now finding the average cost is dividing the total cost by q. So our average cost is simply, so this will be 25 minus 3q plus 1.5 q square. As you know, we divide this every term by the q, we get this very expression. Okay, this is the average cost. Now marginal cost, as you know, is simply the derivative of the total cost function with respect to quantity. So our total cost is this. Now the derivative of q is here 1, so this is 25 minus this 2 becomes coefficient, so 2 3s are 6 q plus here this 3 becomes coefficient, so this here 3 5s are 15, 3 1s are 3 and 4, we get 4.5 q square. Okay, this is the simply that derivative of the total cost with respect to quantity. Now we will equate the marginal cost and average cost. Okay, so equating these two, we will get, that means I will write marginal cost is equal to average cost. So our marginal cost is this, so I will write here 25 minus 6q plus 4.5 q square, and our next term is this 25 minus 3q plus 1.5 q square. Okay, now I have equated them, so I will solve this. This will become minus, this is plus, this is minus. Now this is 25 minus 25 is 0, minus 6q plus 3q, this is minus, this is minus 3q. Here we have plus 4.5 minus 1.5 is 3q square, it should be equal to 0. So this is 3q square minus 3q is equal to 0, or factoring this 3q out, so we will get 3q, here we get q minus 1 is equal to 0. Okay, I hope I make myself clear. I have equated marginal cost with average cost and solving for q. That means our 3q is either equal to 0 or q minus 1 is equal to 0. Now 3q is equal to 0 means q is equal to 0 here. This is q is equal to, transposing this will become 1. But here we can see that in the long run quantity supplied cannot be 0, therefore must produce something. Okay, it can't have the 0 output level, so our q is equal to 1. So we got here quantity supplied by an individual firm in the long run is equal to 1. So this is the first part in solving this question. Next we will calculate the market quantity. Okay, rather first we will calculate the marginal cost. Now since our q is equal to 1, we will put this q is equal to 1 in this marginal cost function. So our marginal cost is equal to, this is 25 minus 6 times q is equal to 1, so 6 into 1 plus 4.5 into 1 square. So this is 25 minus 6 plus 4.5, which is 25 minus 6 is 19 plus 4.5, and which comes out to be this is 5 19, this is 23.5. so our marginal cost is this 23.5. so I will write here, sorry, our marginal cost is 23.5. okay, from the relation we have written in the very beginning, since marginal cost is equal to price, so that means our price is also equal to 23.5. so our price is 23.5. individual quantity supplied by a firm is 1. Now we will calculate the market demand. Okay, our market demand is simply, we will solve this very function with for q, and we know the value of p is equal to 23.5. so I will write here. So next step is to calculate the market quantity. So our market quantity, this is our demand function, p is equal to 2500 minus 0.25 q. Now inserting the value of p is 23.5 is equal to 2500 minus 0.25 q. When solving this will become 0.25 q is equal to 2500 minus 23.5, or 0.25 q is equal to, now this is here 5.67, and this is 4, and this is 2. So we will get, so I will write it here 0.25, or I will simply write it like this. We can write q is equal to 2500 minus 23.5 divided by 0.25. when solving this we will get here, this will come out to be 2476.5 divided by 0.25. when solving this we will get the answer 9906. so quantity supplied is equal to 9906, rather quantity supplied and quantity demanded is 9906. Now we have to see the number of firms. Now number of firms is simply number of firms times the quantity supplied by the individual firm is equal to total quantity. So this is the relationship between the number of firms. So you can easily infer number of firms times the quantity supplied by each, since they are the identical firms here, so this they will rather produce the same level of output. Number of firms times quantity supplied by individual firm should be equal to the total quantity supplied. How our n times quantity supplied by one firm we have seen somewhere here, so this is 1, should be equal to total quantity supplied is 9906. Here we can see n is simply 9906 divided by 1, which is equal to 9906. So we can see here number of firms is equal to 9906. So the correct option, I guess, if I had done the calculation correctly, this would be 9906, 9906 firms. Why? Because every individual firm is supplying one unit. Number of firms are n, so n times the number of units supplied by each industry is equal to total supply. It is very obvious to comprehend this. Next question is, Walras law implies that if there are n markets in the economy, then one only needs to find equilibrium prices in. Options are n minus 2 markets, all n markets, n minus 1 markets, or n plus 1 markets. So correct option, I guess, is n minus 1 markets. That is, if we want to find the equilibrium for n markets, and if we find the equilibrium in n minus 1 markets, that means the last market will also be in the equilibrium. Okay, so if we have, let us say, 8 markets, n is equal to 8, and if we find the equilibrium in 7 markets, that means the last one would also be in the equilibrium. That means n minus 1 markets. Next question is, in a two-country model, an increase in foreign countries' national income generally leads to. So if we have two economics, let us say India and UK, okay. We have two-country model. It says increase in foreign countries' national income. If the national income increases in the UK, so this will lead to the increase in imports. Okay, if there is increase in imports in the foreign country, then this means there would be increased exports in the domestic countries, because we are considering only two-country model. So with increase in foreign income, there would be increase in their imports, and there would be increase in the exports of the domestic country. Okay, so with increased exports, there would be also increase in the domestic output, because some part of the output would be exported and some would be consumed locally. So overall there would be increase in the output also. So the correct option is increase in exports and increase in domestic output. This option is correct. Next question is, GST is options are a destination based consumption tax. Yes, that is true. It is an indirect tax. Yes, GST is indirect tax. A modified form of value added tax. So I'm not sure whether it is a modified value of value added tax in context of India, but in other countries we say value added tax is GST. Value added tax and GST are synonymous in other countries. An origin based tax assigned to state of origin where the sales takes place. Yes, that is true option. So I guess option A, B, and D are correct, and this C could have been also correct. I am not sure about that. So let us see what would be in the key. Next question is, the basic tenets of monetarism are, options are a monetary approach to the balance of payment and exchange rate theory. B option is acceptance of the quantitative theory approach to macroeconomic analysis. C option is an active stabilization policy through expansionary monetary or fiscal policies, and D is a strict rule monetary policy. That is a strict rule based monetary policy. So monetarism is actually, D option is correct, a strict rule based monetary policy, and A option, I guess this is also correct, a monetary approach to the balance of payment and exchange rate theory. Okay. Next question is, inflation increases the average level of prices. Which of the following is or necessarily implied by this statement? The statements are, the prices of commodities exceed income, so this is not necessary. implied by this very statement that inflation increases our average level of prices. The second statement is money supply grows higher than the real GDP. Yes, this option is correct. If money supply increases higher than real GDP, this will lead to the inflation. So increase in money supply will lead to a higher inflation rate. Okay, so I guess the correct option would be B. That is only this very option is correct. Next question is, if expectations about inflation are formed as per rational expectation hypothesis, then the short run Phillips curve will be, the options are coinciding with the narrow, B is negatively sloped, C is parallel to horizontal axis, D is parallel to vertical axis. So we have this, we have unemployment and inflation. In the presence of rational expectation, the short run Phillips curve would be parallel to the this vertical axis. So the correct option, I guess, is D. I don't know the further explanation to this question, but the right option, I guess, is D option. Next question is, if a country has flexible exchange rate regime with perfect capital mobility, then according to Mundell-Fleming model, an expansionary fiscal policy will lead to, the options are reduced net exports, expansion of output, appreciation of nominal exchange rate, and D is no change in output. So let us draw the usual graph of Mundell-Fleming model. We have income on horizontal axis and rate of interest on vertical axis. We have this ICE curve and LM curve and BOP curve. Okay. Now, if there is expansionary fiscal policy, that means government expenditure will increase. This will shift IS to the right, okay, which will lead to the increase in the rate of interest. Let us say originally we have I0 interest rate. Now interest rate will increase to I1. Similarly, Y0, if it was the original output, our new output will be Y1. Okay, so with the shift of IS curve, we have seen IS curve shifting towards the right will lead to increase in rate of interest and output. Okay, that means domestic interest rate would be greater than the international interest rate. This will lead to capital inflow. With capital inflow, we would have the balance of payment surplus. Balance of payment surplus will lead to the appreciation of the currency. Okay, so balance of payment surplus leads appreciation of currency. Okay, so this option C is correct, and expansion of output would be also correct, but the final effect would be with appreciation of the currency, imports will increase, exports will decrease. So IS curve will shift back to its original position. So there will be no change in the output and interest rate in the final outcome. So the fiscal policy, expansionary fiscal policy will lead to be, rather the fiscal expansionary policy will be ineffective in Mundell-Fleming model with flexible exchange rate regime. So I guess the option C, appreciation of nominal exchange and expansion of output, are the correct options, but the final outcome would be only the appreciation of nominal exchange rate. Okay. Next question is, India has highest amount of foreign debt in the form of, options are commercial borrowings, B is loans taken from the International Monetary Fund, C is NRI deposits, and D is loans taken from the Bank of England. So India has highest amount of foreign debt in the form of commercial borrowings. I guess it is somewhat 23% or above, and next comes the NRI deposits. So the correct option in this question would be the first. India is highest foreign debt amount in the form of commercial borrowings. Another question that was asked in GATE economics paper of 2021 was, consider a duopoly market in which the market demand function is as follows: P is equal to 40 minus Q for the two firms producing with identical marginal cost of 10. The Britain Nash equilibrium price will be, the options are 10, 40, 30, 20. So we have to see which of these prices is the Britain Nash equilibrium price. Okay. Now in the Britain duopoly model, as we know, firms compete in prices. So they compete only in the prices and not in the quantity. Okay. Since they have the same marginal cost, that is marginal cost of firm 1 is equal to marginal cost of firm 2, which is equal to 10. So we will see the cases one by one. Let us say the firm 1 sets a price that is lower than the price set by the firm 2. In this case, all the market will be covered by the firm 1 and firm 2 will get zero market quantity. Okay. Second case could be if firm 1 sets a price that is greater than the price set by firm 2. In that case, firm 2 will get all the market, rather will cover all the market, and firm 1 will cover zero market. And another situation could be if price set by firm 1 is equal to price set by firm 2. In that case, market will be split between these two firms. In that case, the quantity supplied by firm 1 is equal to quantity supplied by firm 2, which would be equal to Q divided by 2. Okay. This is the main thing in the Britain equilibrium. So now the question tells us what would be the Britain Nash equilibrium price. Now in the Britain duopoly model, the equilibrium will occur at a point where price is equal to marginal cost. Okay. Since marginal costs are same, marginal cost of firm 1 is equal to marginal cost of firm 2, so we can easily say that the Britain Nash equilibrium price would be 10. Okay, we don't need to calculate anything else here, so the correct option would be 1. And we can also calculate here the equilibrium quantity. Equilibrium quantity would be then, if price is equal to 10 as we have seen, then quantity shared will be, as we have seen, Q1 is equal to Q2 is equal to Q divided by 2. So whatever we get the value of Q, we divided by 2. That will be the quantity supplied by each firm. Okay, so let us give a try to see what would be the equilibrium quantity also. So as we have got price is equal to 10, that is price is equal to 10. We put this price is equal to 10 in this model, this demand function. So 10 is equal to 40 minus Q, or Q is equal to 40 minus 10, that is equal to 30. Then Q1 is equal to Q2, as we have calculated earlier, is equal to Q divided by 2, which is equal to 30 divided by 2. That means each firm will supply 50 units of quantity. So the question was only asking about the Britain Nash equilibrium price. So Britain Nash equilibrium price would have been 10, and the quantity that would be supplied by each firm would be 50. Another question that was asked in GATE economics paper was, let the rate of inflation in an economy be 4.2%, the growth rate of velocity of money be 2%, and growth rate of real GDP be 6%. According to Milton Friedman K% rule, the growth rate of money supply for maintaining stable prices will be So first we know that k% rule of Friedman says we have the equation, the famous equation, that is m v is equal to py, okay, where m is the money supply, v is the velocity, p is the price, and y is the GDP. So k% rule says us that change in the money supply, that is del m plus change in the velocity, should be equal to change in the price plus change in the GDP. Here it is real GDP. Okay, now we have to insert the values only. Here we can see the inflation rate is 4.2, so in place of del p we have 4.2% plus the rate of GDP is 6%. I will write here this is 6%, and change in the velocity is 2%, so I will write here 2% plus our del m is this. Then change in the money supply would be simply this 4.2 plus 6 minus 2, that is 6 plus 4.2 is 10 plus 2 minus 2, that is 10.2 minus 2, which is equal to 8.2%. So the k% rule tells us in this case that money supply should grow by 8%, that is 8.2%, so that to maintain the stable prices. Okay, if we increase the money supply above the 8.2%, then it will lead further problems or inflation, hyperinflation in the economy. Okay, the ideal change in the money supply would be 8.2%. This is the Friedman's k% rule. Next question is, what would be the consequences for the OLS estimator if heterodicity is present in the regression model but ignored? Assume all the other classical assumptions are valid. The options are it will be inconsistent, second is it will be unbiased but inefficient, C is it will be unbiased but inconsistent, and D option is it will be biased. So when there is heterodicity present in a regression model but ignored, its result is that our OLS estimators are unbiased but inefficient. So the correct option would be this B option. Another question that was asked in the GATE economics paper of 2021 was, consider a competitive market where demand and supply functions are given by, that is, this is the demand function is equal to 12 minus 2p and quantity supplied is 4p, where p is the price and q is the quantity respectively. The tax rate per unit of output that maximizes tax yield or revenue is given by, we have to find the tax rate which maximizes the tax revenue. First of all, what will we do? We will write these two very equations. We have q is equal to 12 minus 2p. This is our quantity demanded. So first we find the inverse demand and supply function. So to find the inverse demand function, we will solve this for p. So this will become 2p is equal to 12 minus q, or p is equal to, transposing this will become 6 minus q divided by 2. So this is our inverse demand function. Similarly, we will find the inverse supply function. So q is equal to 4p, okay, or we can write p is equal to q divided by 4. So this is our inverse supply function before the imposition of tax. Okay, this is our supply function, this is our this is supply function, this is demand function. Now if that per unit tax is imposed, our supply function would will look like this. Let us say our PT means the supply function after the imposition of tax would look like this, q divided by 4 plus t. Okay, so okay, I will write it as the subscript here, not to be confused with power. So this is our new supply function after the imposition of per unit tax. Now as we know, in the equilibrium we equate demand and supply functions. So in equilibrium, you are at equilibrium quantity demanded, that is quantity demanded should be equal to quantity supplied, or demand should be equal to supply. Now we will equate the ordinal demand function and new supply function after the imposition of per unit tax. So I will write it here. Our demand function is this: 6 minus q divided by 2 is equal to our supply function is this: q divided by 4 plus t. Okay, now we will solve this for t here. So just transposing, I can write it like this: q minus q divided by 2 minus q divided by 4 is equal to t, or this becomes 6 minus, now this is multiplying by 2, this 2, so this will become minus 2q minus q, this is minus 3q divided by 4 is equal to t, or 3q divided by 4 is equal to 6. So I have transposed this on this side, so this will become 6 minus t, or our q is equal to, this q is equal to 6 minus t multiplied by this 4 by 3, and transposing, and the numerator will become denominator and denominator will become numerator. I hope I am making myself clear here. So our q is equal to, this is 3 1s are 3 2s are 6, so 4 2s are 8. We get here 8 minus 4 by 3t, 4 by 3t. So this is our quantity. We have solved this very function, this demand and supply for quantity. Okay, now tax revenue would be simply tax revenue, or I will write government revenue here, not to be confused with the total revenue. So I will write government revenue is simply quantity times tax. This is our quantity after the imposition of tax. So we multiply this equation with t, so this will become 8 minus t by 3 and multiply it by t, so this becomes 8t minus t square divided by 3. So this is our government revenue. Now our government revenue would be maximum possible only when we differentiate this very function with respect to tax and set it equal to 0. That means government revenue is maximum when we differentiate this function with respect to t. That means dgr divided by dt is equal to, now differentiating, this will become this will become 8, the derivative of t is 1, so this is 8 minus the 2 becomes coefficient, this becomes 2t divided by 3 and set it equal to 0. Now solving this, we will get 2t divided by 3 is equal to 8, or t is equal to 8 into, now in transposing this fraction, so this will become 3 divided by 2, so this is 2 1s are 2 4s are 8, or our t is equal to 12. Okay, that means the tax rate per unit, the tax per unit of output should be equal to 12, so that the tax revenue or tax yield is maximized. Another tricky question that was asked in the GATE economics paper of 2021 was: consider the following demand supply function. Demand function is given as P is equal to Q square minus 12Q plus 35, and supply function is given as 4P minus 3Q is equal to 0. The stable market equilibrium price quantity combination will be, the options are given. We have to see which of the price quantity combinations have the stable market equilibrium. So first of all, what will we do? As usual, we will equate demand is equal to supply. Our demand function is given as, this is q square minus 12q plus 35, and we will, so here we can write this supply function is equal to 4p minus 3q is equal to 0. So I can write it like this: 4p is equal to 3q, or p is equal to 3 by 4q. So this is our supply function. Okay, this is our demand function. I will not write it here. So we equate demand is equal to supply. This is then 3 by 4q. Now solving this will become this, we will multiply this 4, so this will become 4q square minus 48q plus 140 is equal to 3q. Now solving again, we will get 4q square minus 48q, and subtracting this will become 3q plus 140 is equal to 0, or 4q square minus 51q plus 140 is equal to 0. So this is our quadratic equation. We can use the quadratic formula for solving this question. So I will not write what is the quadratic formula. I will just insert the quadratic formula here. Therefore q is equal to minus b, that is this minus b, so this will become minus into minus is plus, this will become 51 plus minus b square means 51 square. 51 square is 2601 minus 4 times a into c, that means 4 into 140, which comes out to be 2240. So I am just trying to save the space. I hope you know this quadratic formula. Twice a, we will divide by 2 into 4, which is 8. Now when solving, this will become 51 plus minus, this is 361 divided by 8, or I can say this is our q. Our q is equal to 51 plus minus, now 361 is 19 divided by 8. So we get two values of q. Either we get q is equal to 51 plus 19, 51 plus 90. So I will write 51 plus 19 divided by 8 will be one value, and another will be q is equal to 51 minus 19 divided by 8. So here it is, and this comes out to be 70 divided by 8, 70 divided by 8, or here it is 32 divided by 8. So we got two values of q here. Because it's a quadratic function, we got two values here. So q is equal to 70 divided by 8, then corresponding price will be equal to, so this is the supply function. We can put the value of q is equal to this 70 divided by 8 into the price function. So this will become 3 by 4 into 70 divided by 8 when solving, and this will come out to be this comes out to be 105 divided by 16. Similarly, when q is equal to 32 divided by 8, which is equal to 4, so here I can write it is equal to 4. I will write this is 4. Now inserting on this very equation, so this is 3 by 4 into 4, or we get price is equal to 4. So we got two values of q. We got p q combination is 105 divided by 16 and 70 divided by 8, and another combination we got pq is equal to, sorry, here 4 and 4 gets cancelled, we get 3. So we get 3 and 4. So these two options are given. So there cannot be two options correct, because it is a MCQ. Only one option can be correct. Either this option is correct or either this option is correct. For that, we need to draw the graph of this quadratic equation roughly. So we can do this. If this is our quantity, this is our price, the graph of this demand function is, so intercept is 35, and this would look like this 35. So this is our demand function, it is quadratic one, and our supply function is this P is equal to 3 by 4 Q. So intercept is 0 and slope is 3 by 4. So supply function would look like this. Okay, now we have to choose here this combination of quantity is equal to 4, price is equal to 3. This is one combination. Here we have 70 divided by 8 and 105 divided by 16. Okay, now we have to see which of these 2 points is the stable equilibrium. Stable equilibrium occurs where we have downward sloping demand function. Here we can see up to this point the demand function is downward sloping and supply function is upward sloping. So we can guess here that this point would be the stable equilibrium here on this point. So if I break this out here, so this would look like this. This is the supply function and this is here the demand function. Here the demand function and supply functions are both upward sloping. Here the demand function is downward sloping, supply function is upward sloping. So this is stable equilibrium, and this is unstable equilibrium, because the question asks us about the stable market equilibrium. I guess the correct option would be this very combination 3 and 4. If I can see here this is 3 and 4, because at this point both demand and supply the demand curve is downward sloping and supply curve is upward sloping, but at this point both demand and supply functions are upward sloping. I hope I make myself clear. So I will just use some time in showing you how I have calculated, how I have used this quadratic formula for those people which don't know how to use the quadratic formula. So I will just rub it here. So we were given this very quadratic equation. Okay, so I will write it here in case I miss the main point is 4q square minus 51q plus 140. I have used the quadratic formula. In the quadratic formula, what we do, the first term, first we write the equation in standard form. By standard form we write the variable with highest power, then the variable with low power, and consequently so we arrange the powers in increasing order. Okay, so let here the coefficient of q square is a is equal to 4. Here the coefficient is b is equal to minus 51, and coefficient of c or constant term is 140. Then we use the quadratic formula. Quadratic formula will be q is equal to minus b plus minus b square minus 4ac divided by twice a. So we use this very quadratic function here. So here we have minus, here then we have another minus of minus 51. Okay, then plus minus b square means this 51 square or minus 51 square minus 4 times a is 4 and c is 140. Okay, divided by 2 times a, our a is 4. So I have just used this very quadratic formula in solving this very question. Another question that was asked in the GATE economics paper of 2021 was, the question is Trisha's consumption preference on biryani, that is denoted by x, and puddling, that is denoted by y, is given by the utility function u of xy is equal to x plus 4y. This is the utility function of the Trisha. The price per unit of biryani is given as 2 rupees and the price per unit of puddling is given as 3 rupees. Trisha's total income is given as 120. However, she faces an extra in quantity constraint as she is not allowed to consume biryani more than 60 units and pudding more than 30 units. The optimum quantity of biryani and pudding consumed by Trisha is, so we are given four options, that is 30, 50, 50, 30, 30, 20 and 60, 0. We have to see which of these options is the optimum quantity of biryani and pudding for Trisha. Okay, so this is the linear programming problem and we will solve it graphically. That means we have to maximize. This is the problem of maximization and we are given the constraints here. So first of all, that means we have to maximize this. That is, we have to maximize the utility, that is x plus 4y. Okay, now what are our constraints? Price per unit of biryani is 2 and price per unit of pudding is 30. That means 3 is, sorry, it is 2, subject to the constraint, that is 2 times the units of biryani, that is x, plus 3, which is the price of pudding, times the units of pudding are to be consumed, which is denoted by y. And our budget constraint is given as it should be less or equal to 120. This is our first constraint. Another constraint which the Trisha faces is given as, that is she is not allowed to consume biryani more than 60 units. So that means next constraint is she can't consume more than 60 units of biryani. That means number of units consumed should be less or equal to 60 of biryani. Similarly, the number of units of pudding consumed should be less or equal to 30. Okay, we have to find the optimal solution to this problem. So how will we find the optimal solution? First of all, we will convert the inequalities into equalities. That means, so I will write it here, we have to maximize utility, which is x plus 4y, subject to the constraint 2x plus 3y is equal to 120. So first we convert all inequalities into equalities, and another constraint is x is equal to 60 and y is equal to 30. This is the first step in solving the linear programming problem by graphical method. After that, we take this first constraint and graph it out, then take second constraint and third constraint and graph them correspondingly. Now how will we graph this? We will find the value of x and 0 here, sorry, x and y here. So for first we have 2x. So first I will draw the graph to save the space then. Okay, this is this horizontal axis denotes the units of biryani and this vertical axis the units of pudding. So we will solve this very constraint first. This is 2x plus 3y is equal to 120. Now we first put x is equal to 0, put x is equal to 0, then 3y is equal to 120 or y is equal to 40 implies y is equal to 40. So our point is 0, 40. Second, we put y is equal to 0, then 2x is equal to 120. That means 2. So I will write put y is equal to 0. When we put y is equal to 0 in this, so this whole term becomes 0. 2x is equal to 120 implies x is equal to 60. So our new point is 60 and 0. Okay, so we draw this constraint here. We have, so I will write here, this is 10, 20, 30, 40, 50, 60 and 70. Let us say this is 10, 20, 30, 40, 50, 60 and let us say it is 70. Okay, so we draw the first constant 2x plus 3y is equal to 120. So we get the first point is 0, 40. That means we have to take here, this is 40 on y-axis and 0 on x-axis. So this is the one point. Similarly, another point is 60, 0. That is on x-axis. We have to run 60 units. So this is 60 and 0 units up. So this is our first constraint. Okay. Now we are given the two constraints, x is equal to 60. So our new, when x is equal to 60, our line would look like this. This is x is equal to 60. Now y is equal to 30. So the graph for y is equal to 30 will be parallel to x-axis. So this is like this. So we draw the three constraints on the graph. Okay. After that, what will we do? We will find the feasible region. Feasible region is a region which is a common region determined by all the constraints. So this is constraint 1, 2 and 3. The common region of all these three constraints is the feasible region. That means this very region would be the feasible region. Our solution will be in this feasible region. So this is the feasible region for this problem, because as I told you, feasible region is a region which is common region determined by all the constraints. Okay, so the common area of all the constraints gives us the feasible region. Okay, now we will use the corner point method in finding the optimal solution to this problem. So the optimal solution of this problem will lie on the corner points of these feasible region. So our corner pointers is, let us say this is O, this is A, this is B and this is C. So our optimal solution will lie on the corner pointers. Okay, now here we know the coordinate of O is 0, 0. So I will write 0, 0. The coordinates here is the coordinates of A is here 0, 30. The coordinates of C are 60 and 0. So we will find the coordinate of B first. Now this B point is formed by the intersection of this constraint, that is 2x plus 3y is equal to 120. So this line, and y is equal to 30. So these 2 points will give us these two constraints will give us the coordinates of B, but we know one coordinate is 30. We have to find the another coordinate, the value of x. So we will solve these two equations. Now when y is equal to 60, we put the value, y is equal to 30, we put this in the first constraint. So this is 2x plus 3 times the value of y is 30 is equal to 120, or 2x is equal to 3 30s are 90. So 120 minus 90 is 30, implies x is equal to 30 divided by 2, which is equal to 15. So here it is 15. So the coordinates of this point are 15 and 30. Okay, so we got the coordinates of all the pointers. We will see which of these coordinates will maximize our utility function, which is the objective function here. So our corner pointers are, O, A, B, C, O, A, B, C. The value of O is 0, 0. The value of A is 0, 30. the value of B is 50 and 30, 50 and 30, and the value of C is 60 and 0. So we will put these values in the objective function, that is x plus 4y. We will put, and we will see which of these which among these coordinates will maximize our utility. Now when we put x is equal to 0, y is equal to 0, so here it is 0. Now when x is equal to 0, y is equal to 30, so this is 4 into 30, which is 120. So we will get here 120. Now when we put x is equal to 15, so here it is 15 plus 4 into 30, that is 120, which is equal to 135. In the last we have x is equal to 60 plus 4 times it is 0, so we will get 60. And we can easily see that this point, that is point B, will rather give us the optimal values of this very function, because the maximum solution from the maximization, here we see the maximum possible value is 135, which occurs at a point B, that is at point B 1530. So the optimum quantity of the biryani and pudding consumed by Trisha will be 50-30. So I guess this very option, that is the option B, is correct. Another question that was asked in the GATE Economics paper of 2021 was about the pure strategy Nash equilibrium. The question is, consider an intersection of the roads with without any traffic lights. Two cars, car A and B, approach an intersection and they want to proceed as indicated by the respective arrows in the following diagram. I have not shown here the diagram. If both proceed without stopping, then there is an accident. Okay, up to this I will first draw the payoff matrix to make the things clear. Okay, we have the two cars. Let us say we have car A and car B. Car A has two choices, either to proceed or to stop. Similarly, car B has two choices, either to proceed or to stop. Okay, now we will go to the question. The question says, if both proceed without stopping, there is an accident, then A would have a payoff of -10 and B would have the payoff of -500. That means if both proceed, then A would have payoff of -10. So this -100 is the payoff of A, and -500 is the payoff of car B when both choose to proceed. P and P, I have denoted proceed by P. Okay. Next, the question says, if one stops and other proceeds, the payoff is -5 and 10. That means if one stops, let us say if A stops, its payoff would be -5, and car B proceeds, its payoff is 10. Similarly, in this cell, if car B stops, its payoff would be -5, and if car A tries to proceed, its payoff is 10. Okay, I hope I am making myself clear up to this point. Now, if both of them stop, then it takes little longer to reach their respective destinations. They have a payoff of -5 each. That means if both try to stop, then their respective payoffs is -5 and -5. Okay, the question tells us, find the pure strategy Nash equilibrium of the players. So by Nash equilibrium, as we know, Nash equilibrium refers to a condition in which every party has optimized its outcome based on the other player's expected expected decision. Okay, now we will try to see the Nash equilibrium. So I will just change the color here. Okay, now we will see this very column first. This column says If B chooses to proceed, if car B chooses to proceed, car A has two options, either to proceed or stop. Okay. So if it tries to proceed, it has the expected payoff of -100, and if it tries to stop, it is expected payoff is -5. Here we can see that -5 is greater than -100, so car A would choose to stop. Okay, if car B has chosen to proceed, because -5 is greater than -100, so it will choose this very -5. Okay, so this is for the column first. Let me delete. So this is for column and this is for player A. Now we go to this column and see what are the strategies for player car A, given the strategy of car B is to stop. Now if car B tries to stop, car A has two options, either to proceed or stop. Now if it tries to proceed, its payoff is 10. If it tries to stop, its payoff is -5. Between these two numbers, we can see that 10 is greater than -5. So the car A would choose to stop. Sorry, car A would choose to proceed because it will get more payoff in proceeding rather than in stopping. So for player A, this -10 would be better than -5. Okay, now I will just try to erase something here because of the lack of the space. So this is for player A when player B has chosen stop. Now we will see horizontally what are the optimal choices for player B. Okay, now here player A has stopped. If player A tries to proceed, if player A tries to proceed, player B has two options, either to proceed or to stop. If it tries to proceed, its outcome expected payoff is -500. If it tries to stop, then its payoff is -5. Between these two numbers, we see that -5 here it has more payoff than in this row, in this cell, so it would choose this -5 because -5 is greater than -500, so it will choose this -5. Okay, so let me just erase. So player car B would choose to stop if A chooses to proceed. Now we will go to this very horizontal section. Now here we can see if player A tries to stop, player B has two choices, either to proceed or stop, and the expected payoff is 10 and -5. Here we can see that if it tries to proceed, it has more payoff than in stopping because 10 is greater than -5, so it would choose this 10 as it is strategy. Okay, I hope I am making myself clear, and it gets messy here. I am very sorry for that. So we can see we have that two Nash equilibriums here, or multiple Nash equilibriums here. Nash equilibrium is obtained where both the parties have chosen their optimal decision. So here we can see this is the Nash equilibrium, and this is also the Nash equilibrium. Okay, now we have the choices. The choices are, first option is car A, car B. Here what does this mean? This means car A has stopped, car B has proceeded. So car A, B, stop, proceed is one Nash equilibrium. So this option is correct. Similarly, this second Nash equilibrium is that car A proceeds and car B stops. So if there is that very option, we can see we have proceed and stop for car A and B. So I guess these two options are correct because the question was multi-select question. I hope I make myself clear in this video. Another question that was asked in the GATE economics paper of 2021 was, for the production function Q is equal to under root of KL with price of capital given as 4 and price of labor given as 2, find the values of capital and labor that will minimize the cost of producing 2 units of output. So we have to minimize the cost in this question because it is the cost minimization problem subject to the production constraint that is under root KL is equal to 2 units. So our question is, we have to minimize the cost. Now what is cost here? Price of capital is 4, so 4 times the units of capital, 4k plus 2 times the units of labor. Minimize this very cost subject to the production constraint. Our production constraint is k to the power 1 by 2, L to the power 1 by 2 should be equal to 2, because this is our minimized cost subject to the production constraint of producing 2 units with the given production function. So first of all, as we know, this is called objective function. This is the constraint. The first step is we set this constraint equal to 0. That means 2 minus k to the power 1 by 2, L to the power 1 by 2 should be equal to 0. Next step is we multiply this constraint by lambda. So this becomes lambda times 2 minus k to the power 1 by 2, L to the power 1 by 2. So these are the two steps you should understand easily. First we write this constraint function, set it equal to 0 and multiply it by lambda. Okay, after that we are able to form the Lagranges function. Now our Lagranges function, I will write it by U. Lagranges function is simply the addition of the objective function and the resulting constraint function. Our objective function is this 4k plus 2L, and we add this very resulting constant, that is plus lambda times 2 minus k to the power 1 by 2, L to the power 1 by 2. Now this is our Lagranges function. We partially differentiate. The next step is we partially differentiate the Lagranges function with respect to capital, labor and lambda and set them equal to 0 simultaneously. Okay, so first partially differentiating with respect to, let us say we differentiate with respect to L. So here 4k, no L is involved. Here the derivative of L is 1, so we get here 2. Here we have the lambda, we have here L this, so 1 by 2 will become the coefficient. We will get here this is minus 1 by 2 lambda, okay, k to the power 1 by 2 and L to the power, this minus 1 by 2 get subtracted by 1, so this becomes minus 1 by 2 by the law, by the power function rule. This 1 by 2, this exponent becomes coefficient and exponent is subtracted by 1. Okay, and we set it equal to 0. Now when set it equal to 0, we will get 1 by 2 lambda k to the power 1 by 2, L to the power minus 1 by 2 is equal to 2. Okay, similarly differentiating with respect to k, so the derivative of k is here 4, we will get 4, derivative of k is 1, 4 times 1 is 4. Similarly here we will get minus 1 by 2 lambda k to the power minus 1 by 2, L to the power 1 by 2. Why? Because we are simply differentiating this time with respect to k and set it equal to 0, and solving further this will become 1 by 2 lambda k to the power minus 1 by 2, L to the power 1 by 2 is equal to 4. Okay, and similarly we partially differentiate this with respect to lambda, so we will get 2 minus k to the power 1 by 2, L to the power 1 by 2 is equal to 0, and further solving this will become k to the power 1 by 2, L to the power 1 by 2 is equal to 2. Okay, let this be equation first, second and third. Now we divide equation first by second. So dividing equation first by second, so what will we get? We have 1 by 2 lambda k to the power 1 by 2 L to the power minus 1 by 2 divided by this second equation 1 by 2 lambda k to the power minus 1 by 2 L to the power 1 by 2, which is equal to 2 by 4. This 1 by 2 gets cancelled, lambda gets cancelled, so we get here. Now here k to the power minus 1 by 2, we transpose this to the numerator, the exponent becomes positive. So this is k to the power 1 by 2 times k to the power 1 by 2. So I will write here k to the power 1 by 2, k to the power 1 by 2. Similarly, we have L to the power 1 by 2. We take this numerator of L to the power minus 1 by 2 to the denominator. The power gets changed. So here is minus 1 by 2. So this will become 1 by 2. Positive 1 by 2 is equal to 2 by 4, which is equal to 1 by 2. So I will write here 1 by 2. Okay, I hope I am making myself clear. I have made the videos on the optimization problems, so you can check out there also. Now this is k to the power 1 by 2. K to the power 1 by 2 is k divided by L is equal to 1 by 2, or our k is equal to 1 by 2. K is equal to 1 by 2 L. So the value, this is our relationship between capital and labor. Now we insert this value in our third equation, okay, to get the value of k. Our k is this, so here in place of k I will write 1 by 2 L, it is whole power 1 by 2, and we have L 1 by 2, which is equal to 2, and we can write it here like this. I can write it as this is 1 divided by 2 under root L to the power 1 by 2, L to the power 1 by 2 is equal to 2, or this is simply 1 divided by under root 2. Now same exponent, same basis, so exponents gets added, so this is L is equal to 2, or we can write L is equal to 2 under root 2. So our optimal level of labor is 2 under root 2. Now to find the optimal level of capital, we substitute this L is equal to 2 under root 2 in the equation third. So I will write k to the power 1 by 2. Here we have k to the power 1 by 2. In place of L, I will write this 2 under root 2. 2 under root 2 power 1 by 2 is equal to 2. So we can write it is here like this, k times 2 under root 2 whole power 1 by 2 is equal to 2. Now transposing the exponent on RHS, so we will get k times 2 under root 2. So the power becomes square when transposing, or rather the root becomes square when transposing to RHS. So this will become 2 square, that is 4. Okay, or we can write it like this, k is equal to 4 divided by 2 under root 2, and rationalizing, so this will become 2 under root 2 divided by 2 under root 2. So this is here 4 2s are 8 under root 2, 8 under root 2. We get here 2 2s are 4, and root this will become 2. So 2 2s are 4, 2s are 8. So we get here 8. So solving this, we will get the value of k is equal to under root 2. So the optimal level is L is equal to 2 under root 2, and capital is equal to under root 2. This option is right. Another question that was asked in the GATE economics paper of 2021 was, given below is an inter-industry transaction matrix. We are given an inter-industry transaction matrix. If final demand for agriculture sector changes from 150 to 300 units, so there is change in this from 150 to 300 units, and for manufacturing sector changes from 120 to 200 units, then the output of the agriculture sector should be of dash units. We have to see that what will be the level of output of agricultural sector when there is change in the final demand of the agriculture sector from 150 to 300 units. So I have labeled here this very element A11, A12, A21, A22, the total output by X1 and X2. Now we will see what does this element, these elements tell us. Now first of all, we have A11 is equal to 500. Okay, now what does this tell us? It simply tells us rupees value of output of agricultural sector consumed by the agriculture sector itself. Okay, similarly we have A12 is equal to 350. This also tells us rupees value of output of agriculture sector consumed by manufacturing sector, and we have A21 is equal to 320. So this is here 320, I will write it here, this is 320. So this tells us rupees value of output of manufacturing industry, rather manufacturing sector consumed by agriculture sector. This is 320. And we have similarly A22, it tells us rupees value of output of manufacturing sector consumed by manufacturing sector itself. So this is 360. First step is labeling them and finding A11, A12, A21 and A22. After that we will see the per unit worth of dollar of each entry. This is done by, we form new element, that is B11. B11 is formed by simply A11 divided by X1. So our A11 is 500. This is 500 divided by 1000, which comes out to be 1 by 2. Okay, now what does this tell us? It simply tells us the rupees value of this B11 tells us rupees value of input from agriculture industry required to produce 1 rupees worth of output of agriculture sector. Okay, this is 1 by 2. Similarly we have B12. So I will write here, B12 is equal to A12 divided by X1, X2, and it tells us, this B12 tells us the rupees value of input from agriculture industry required to produce 1 rupees worth of output of manufacturing industry or manufacturing sector. So this is here, our A12 is 350 divided by 800. Okay, which comes out to be 7 by 16. Similarly we have B21 is equal to A21 divided by X1, which is equal to 320 divided by 1000, which comes out to be 8 by 25. And we have B22, which is equal to 360 divided by 800, which comes out to be 9 by 20. I have calculated these values, so I am writing here. Okay, after that we have to form technological matrix or technology matrix. So I will write B, let us say B is our technology matrix, is composed of all these per unit worth of output of each element. So this is B11, B12, B21 and B22. This is our technological matrix, which is simply here, this is 1 by 2, this is 7 by 16, and this is 8 by 25, and this is 9 by 20. Okay, I hope I am making myself clear. After that we form the Leontic matrix, which is formed by I minus B. That means this is identity matrix, and from that we subtract this technological matrix. So I minus b is our, simply this is 1 0 0 1. This is identity matrix. From there we subtract this b, which is 1 by 2, 7 by 16, 8 by 25, and 9 by 20, which comes out to be, so 1 minus 1 by 2 is 1 by 2. This is minus 7 by 16. This is minus 8 by 25, and this is now 20 minus 9 is 11 divided by 20. So this is our Leontic matrix. Okay, I hope I am making myself clear. The question is rather lengthy. After that, what will we do? We will find the determinant of this Leontic matrix. So determinant is simply we multiply the principal diagonal elements, and from that we subtract the product of the non-principal diagonal elements. So this is equal to 1 by 2 into 11 by 20. This is 11 by 40. This will become 11 by 40. So I will write 11 by 40 minus 8 sevens are 56. 56 divided by 25 times 16 is 400. When solving this, we will get I minus b is equal to 27 divided by 200. So the determinant is this, our I minus b, which is Leontic matrix, is equal to 27 divided by 200. Okay, now after that the next step is to find the adjoint of the Leontic matrix. Okay, so adjoint of Leontic matrix I minus b. How do we find the adjoint? If we are given a 2 by 2 matrix, the adjoint is formed by we interchange the principal diagonal elements. Okay, so adjoint is simply we interchange here. This is 11 by 20, it will come on top 11 by 20, and this 1 by 2 will go here. 1 by 2, sorry, this is 1 by 2. I will write it, this is 1 by 2. Similarly, so the trick is to interchange the principal diagonal elements and change the sign of the non-principal diagonal elements without interchanging their positions. We only change the signs. So if it is here minus 7 by 16, this will become 7 by 16. If it is here 8 by 25, this will become plus 8 by 25. Okay, we have done nothing. We have interchanged the principal diagonal elements, and we have only changed the sign of the non-principal diagonal elements. Okay, so this is our adjoint. After that, we have to find the inverse. Okay, now the inverse is given by inverse, that is I minus b inverse is simply 1 divided by the determinant. Our determinant is I minus b times adjoint of I minus b. So we have got all the values here. So I will write it here. 1 divided by the determinant. The determinant is this, so this will get transposed. 27 divided by 200. This will become 200 divided by 27. So this is 200 divided by 27 is, I will write here 0.74. Okay, 1 divided by this, so I have just saved the space here, multiplied by the adjoint. We got the adjoint, so I will write it in fraction, in decimal. So this is 0.55. this very, here it is 0.0.44 0.32 and 0.5. okay, this is our inverse. Now multiplying, we will get 0.41, 0.33, this is 0.24 and 0.37. This is our, so I will write this is our inverse. I minus B inverse is equal to this very matrix. After that, now to find the change in the output level when the final demand of agriculture sector changes from 150 to 300 and for manufacturing from 120 to 200. So we will write the relationship between our output level will be equal to, that is x is equal to I will write here I minus B inverse times the new demand, that is D complement. Our new demand is 300 and 200. So I will write here, now x is our x1 complement, x2 complement. So this will be the change in the output when there is change in the final demand in agriculture sector and and in manufacturing sector. So this is our matrix: 0.41, 0.33, 0.24 and 0.37, and we multiply it by the new demand, which is 300 and 200. Now when solving, this will become, now this is 0.41 into 300, which comes out to be 123, plus 0.33 times this 200, this is 66. Similarly 0.24 into 300, which is 72, and 0.37 into 200 is equal to 74. So this is our new matrix, that is change in the final demand. This is 189, 6 3 is 9, this is 189 divided by, we don't divide here, so 4 2 is 6, 7 7 is 14. So we can say that change in x1 is equal to 189. Our output level of agriculture sector should be this 189, and for manufacturing sector it would be 146. okay. Next question is, PQ faces a lottery with outcome of 24, 12, 48 and 6 given the following probability distribution. We have the lottery outcome and correspondingly their probability of outcome. She is indifferent between lottery and receiving 28 with certainty. So receiving 28 with certainty and playing the lottery, she is indifferent between these two. Given the information, we conclude that PQ is a options are hedger, risk neutral, risk averse or risk lover. So we will see what is the behavior of the PQ. If our expected utility from the lottery is greater than this 28 which she receives with certainty, we would say that she is a risk lover. If the expected utility of lottery is less than and the 28 which she receives with certainty, then in that case we would say she is risk averse or risk hater. Okay, so we will see the expected utility of lottery would be simply we multiply lottery outcome by their corresponding probabilities and add them. So we have 24 into 2 by 6 plus 12 into 3 by 6 plus 48 into 1 by 6 plus 6 into 0. When solving, this will be 6 1s are 6 4s are, so 4 2s are 8. We get here 8. Here we have 6 and here we have 8, and 6 into 0 is 0. So expected utility from lottery we get 22. Since 22 is less than 28 which she will receive which she receive with certainty, we can say that she is risk averse, that is risk hater. If the expected utility of lottery would have been greater than the 28, then in that case we would have said that she is a risk lover. If the expected utility was equal to 28, in that case we could have said that she is a risk neutral. So the correct option, I guess, in this case is C, that she is risk averse. The long run cost function of all identical firms in a perfectly competitive industry is given by the function that cost is 25q minus 3q square plus 1.5q cube. The market demand function is given by that is P is equal to 2500 minus 0.25, where Q is the total quantity and P is the price. The number of firms in the industry at equilibrium is, we have to find the number of equilibrium firms. So how we will find that? First of all, we are being told about the long run. Okay, we know that in long run, price should be equal to marginal cost, which should be equal to average cost. This is the equilibrium condition for any individual firm's output level, optimal output level. So this condition must be held. Okay, so we will find the marginal cost and average cost. Okay, our average cost is simply, so I will write our total cost function is given as 25q minus 3q square plus 1.5q cube. Now finding the average cost is dividing the total cost by q. So our average cost is simply, so this will be 25 minus 3q plus 1.5 q square. As you know, we divide this every term by the q, we get this very expression. Okay, this is the average cost. Now marginal cost, as you know, is simply the derivative of the total cost function with respect to quantity. So our total cost is this. Now the derivative of q is here 1, so this is 25 minus this 2 becomes coefficient, so 2 3s are 6 q plus here this 3 becomes coefficient, so this here 3 5s are 15, 3 1s are 3, and 4, we get 4.5 q square. Okay, this is the simply that derivative of the total cost with respect to quantity. Now we will equate the marginal cost and average cost. Okay, so equating these two, we will get, that means I will write marginal cost is equal to average cost. So our marginal cost is this, so I will write here 25 minus 6q plus 4.5 q square, and our next term is this 25 minus 3q plus 1.5 q square. Okay, now I have equated them, so I will solve this. This will become minus, this is plus, this is minus. Now this is 25 minus 25 is 0, minus 6q plus 3q, this is minus, this is minus 3q. Here we have plus 4.5 minus 1.5 is 3q square, it should be equal to 0. So this is 3q square minus 3q is equal to 0, or factoring this 3q out, so we will get 3q, here we get q minus 1 is equal to 0. Okay, I hope I make myself clear. I have equated marginal cost with average cost and solving for q. That means our 3q is either equal to 0 or q minus 1 is equal to 0. Now 3q is equal to 0 means q is equal to 0 here. This is q is equal to, transposing this will become 1. But here we can see that in the long run quantity supplied cannot be 0, therefore must produce something. Okay, it can't have the 0 output level. So our Q is equal to 1. So we got here quantity supplied by an individual firm in the long run is equal to 1. So this is the first part in solving this question. Next, we will calculate the market quantity. Okay, rather first we will calculate the marginal cost. Now since our Q is equal to 1, we will put this Q is equal to 1 in this marginal cost function. So our marginal cost is equal to, this is 25 minus 6 times Q is equal to 1, so 6 into 1 plus 4.5 into 1 square. So this is 25 minus 6 plus 4.5, which is 25 minus 6 is 19 plus 4.5, and which comes out to be this is 5 19, this is 23.5. so our marginal cost is this 23.5. so I will write here, sorry, our marginal cost is 23.5. okay, from the relation we have written in the very beginning, since marginal cost is equal to price, so that means our price is also equal to 23.5. so our price is 23.5. individual quantity supplied by a firm is 1. Now we will calculate the market demand. Okay, our market demand is simply, we will solve this very function with for Q, and we know the value of P is equal to 23.5. so I will write here. So next step is to calculate the market quantity. So our this is our demand function. P is equal to 2500 minus 0.25 Q. Now inserting the value of P is 23.5 is equal to 2500 minus 0.25 Q. When solving this will become 0.25 Q is equal to 2500 minus 23.5, or 0.25 Q is equal to, now this is here 5.67, and this is 4, and this is 2. So we will get, so I will write it here 0.25, or I will simply write it like this. We can write Q is equal to 2500 minus 23.5 divided by 0.25. when solving this we will get here, this will come out to be 2476.5 divided by 0.25. when solving this we will get the answer 9906. so quantity supplied is equal to 9906, rather quantity supplied and quantity demanded is 9906. now we have to see the number of firms. Now number of firms is simply number of firms times the quantity supplied by the individual firm is equal to total quantity. So this is the relationship between the number of firms. So you can easily infer number of firms times the quantity supplied by each, since they are the identical firms here, so this they will rather produce the same level of output. Number of firms times quantity supplied by individual firm should be equal to the total quantity supplied. How our N times quantity supplied by one firm we have seen somewhere here, so this is 1, should be equal to total quantity supplied is 9906. Here we can see N is simply 9906 divided by 1, which is equal to 9906. so we can see here number of firms is equal to 9,906. So the correct option, I guess, if I had done the calculation correctly, this would be 9,906 firms. Why? Because every individual firm is supplying one unit. Number of firms are n, so n times the number of units supplied by each industry is equal to total supply. It is very obvious to comprehend this.